Particle moves from one position to another in 13 seconds as shown in the velocity time graph over here. Determine the maximum acceleration during the journey. Identify any point in time when the object does not accelerate. Determine if there was any deceleration during the journey, and if so, its value. So there's a lot of question being asked. We'll go sub question by sub question. Determine the maximum acceleration during the journey. Okay, I will zoom in for you guys. I'm sure you will not be able to see this graph properly. So we're looking at maximum acceleration, right? So that's the first question. So figure it out where it is. Yeah, so I think this has the maximum slope 6 to 8. 0 to 4 we have 40, so that will be 10. 6 to 8, that is 2, and we have 60, 30. And 8 to 13, it's 5, and 100 to 0, this is 20. Actually, I found all the slope. So minus 20. This would be 10, and this would be 60, right? 60 and 230. So what did I find? In velocity time graph, first thing is we're looking at velocity time graph. In velocity time graph, if we find the slope, we are finding, yes, acceleration. So you're pretty much able to answer all of it. And one last thing, what is the slope over here? 0. So I think you should be able to answer all of this now. Identify any point where the object is not accelerating. Determine if there is any deceleration during the journey, and if so, its value. Okay, so I actually kind of answered all of it. Quite simple actually. So what I used was slope is equal to change along y by change along x. If not, you might know it as rise by run. In this case, along the y we have velocity, along x we have time. And this is nothing but your definition of acceleration.